Regarding the need for a ground loop or counterpoise for your pad-mounted 3-phase 300 kV amps delta Y connected 208 divided by 120 volts 12,460 volts primary transformer, the question is whether a ground loop or counterpoise is required in addition to your existing 10-foot ground rod. In most cases, the existing ground rod is sufficient for grounding a pad-mounted transformer, particularly if it is already installed and functioning correctly. This applies in many typical installations. The second question is, if a ground loop or counterpoise were to be installed, would it need to be tied into the facility ground for the nearby building? It is recommended to bond the ground loop or counterpoise to the facility ground of the adjacent building. This practice creates a low impedance path for fault currents, which is essential for effective fault clearing and personnel safety. Connecting to the facility ground provides an additional measure of protection against lightning strikes by helping to dissipate the energy to ground. There are several factors that should be considered in determining whether a ground loop or a counterpoise is required. 1. Soil conditions. The soil's resistivity impacts the effectiveness of a grounding system. High soil resistivity may necessitate a ground loop or counterpoise to achieve the desired low grounding resistance. Soil resistivity can vary greatly depending on the soil type, moisture content, and temperature. High resistivity makes it difficult for current to flow into the earth, thus requiring a more extensive grounding system. 2. Local codes and standards. Electrical codes and standards specific to your location may dictate specific grounding requirements for pad-mounted transformers. Consultation with a licensed electrical engineer or qualified electrician is necessary to ensure compliance with all applicable regulations. These regulations are in place to ensure safety and proper equipment operation. 3. Availability of space. Ground loops and counterpoises require a certain amount of surrounding space. If physical space is limited around a transformer, implementing these additional grounding measures might be challenging. Space constraints could influence the feasibility of these designs. 4. Cost. Installing a ground loop or counterpoise introduces additional expense to the project. A cost-benefit analysis should be performed to determine if the added expense is justifiable in light of the specific circumstances. This analysis should consider the potential benefits of enhanced grounding versus the additional cost. Recommendation based on the provided information. You likely can operate using only the existing ground rod. However, it is highly recommended to consult with a qualified electrical engineer or licensed electrician familiar with local codes and site conditions. They can evaluate the specific characteristics of your installation and provide tailored recommendations for the most appropriate grounding solution. A thorough assessment will ensure both safety and regulatory compliance for your pad-mounted transformer installation. They will consider soil resistivity testing, local electrical codes, space constraints, and budget considerations to arrive at the optimal grounding strategy.